Hello, my name is ABRAR ID 171011217. So the title of our project is Barrier Preventing Line Follower, where our initial goal is to create a system which would detect its surroundings with no extra human involvement. This could be used in traditional conveyor belts, in autonomous vehicles, to serve as a path guidance, and in many more cases. Here we'll initially use 5 types of components, starting with Arduino Uno, which will be the brain of our project. Then we have our L298N DCM driver, which is a dual bidirectional motor driver. And then following that we have our two DC motors, followed by our two IR sensors over here, which will keep the track of the lines on any background. Then finally we have our ultrasonic sensor, which uses a sonar to determine the distance between any objects, which will give us at least 2 centimeters to 400 centimeters of non-contact measurements. Thank you.
Everyone, my name is Naeem Hafiz and my ID is 171012444, and today I will be defining the code that we used for our obstacle avoiding line follower robot. First of all, we have defined trick pin and echo pin, which will be used as the pins for the ultrasonic sensor, and this will be connected with A1 and A0 pin of the Arduino. Then we have defined two global variables named duration and distance. Duration is basically the time for the signal to go and come back, and distance is the distance between the obstacle and the bot. Then we have defined the setup method through which we'll be defining the pins that will be acting as input and output. Then we have defined the sonar method where we'll be defining the ultrasonic sound which will be sent with some delay timing. Here we can see that we have mentioned a delay of 2 microseconds, through which we get to know that after 2 microseconds another ultrasonic sound will be sent, and we have also seen a delay of 10 microseconds, through which we get that after 10 microseconds another ultrasonic sound will be sent. Now we have calculated the duration through which we get to know the time for the signal to be received by the receiver, and we have also calculated the distance between the bot to the obstacle in centimeter over here. Then we have mentioned the stop method, in which we'll be getting to know how we'll stop the bot. And after that we have defined two toggle view and S for IR1 and IR2. Then we have called the sonar method to find out the distance through which we'll be figuring in which way the motor will be moving. Here we see a combination where the toggle for IR1 and IR2 are both 1. That means the motor will be moving anti-clockwise, and if the distance exceeds the condition, then we'll call the stops method to stop the bot. Again, we see that the toggle for IR1 and IR2 are 1 and 0 respectively. Then it means that the motor will have a change in direction, and if the distance exceeds the condition, then we'll call the stops method to stop our bot. Again, we see the same condition but in a different way. Here the toggle for IR1 and IR2 are 0 and 1 respectively. That means the motor will have a change in the direction, and if the distance exceeds the condition, then we will call the stops method to stop our bot. Finally, the toggle for IR1 and IR2 are both 0. That means the motor will be moving clockwise, and if the distance exceeds the condition, then we'll call the stops method to stop our bot.
I am RABEYA ID 1810147 from section 2. In our project, we need some components to detect the color and obstacles. Here we use Arduino Uno, L298N motor driver, 2 DC motors, 2 IR sensor and ultrasonic sensor, and 2 logic toggle. From pin 13 to 10 is connected to the motor driver pin IN1 to IN4, and pin 3 is connected to the IR1 sensor out pin, and pin 2 is connected to the IR2 sensor out pin. Then we will add trigger and echo pin to the Arduino Uno A1 and A0 pin respectively. Both of these DC motor is connected to the out pin of L298 motor driver. Then we will add a logic toggle which is connected to this test pin of both of these sensors. We need a ground and a power source which is connected to VCC and ground respectively for both of these sensors. These two pins and this ground pin is connected to this ground, and we need DCCs which is connected to this 5 volt and this 12 volt. From ultrasonic sensor, 5 volt is connected to this 5 volt and this ground pin is connected to this motor driver ground pin. When we run our code, we can see that for 00 logic the motor will rotate clockwise, and for 11 logic the motor will rotate anti-clockwise. For 10 and 01, both of these cases, it can change its direction. Whenever it detects any obstacles from greater than 4 cm, the motor will be stopped. Thank you.
Well, hello, my name is Rashik ID 17101158, Section 2 of CSC 360 course. Well, previously you have understood how the Proteus simulation is done from my group members NAYEEM, ABRAR and RABEYA. In conclusion, it can be said that the line follower robot has a configuration that is identical to that of a line follower robot. Besides sensing the light, the sensor can also solve multiple problems. Barrier preventing robots can be used in a wide range of situations. They can be used as service robots to perform household tasks. To avoid barriers, line follow robots should gather enough information about its surroundings beforehand. Well, people nowadays expect robots to identify and avoid barriers in everyday situation. An industrial robot, for example, is supposed to avoid workers from being injured severely. Well, to sum up, it can be finally said that barrier preventing robots is a widely studied technology around the world, and it is likely that most robots will have this capability in the future. Well, that was all from Team Alpha 360. Well, it was a pleasure doing this course with my team members NAYEEM, ABRAR and RABEYA. Well, that is all from us. Allah Hafiz.